Students, yeah, this video clip will introduce the asset allocation model. Once we complete this capital allocation model using the maximum the utility, now how do we allocate the risky assets? Two risky assets will start. Two risky assets into this the weight of the risky portfolio. So here we assume that we invest two different type of risk asset. One is debt, the other one is equity. It's the risk asset has the expected rate of return and the standard deviation. Once we include the two different types of assets, they have different correlation coefficient. Here in this case is 0.23, right? 0.23. So this is the given information. We need to calculate covariances because covariances explains how different they are. If the covariance is positive, which means the correlation is between 0 to 1, that makes the deviation, right? More the standard deviation of the risky asset portfolio. If the correlation coefficient is negative, then yeah, this covariance is also negative, right? So we need to calculate covariances. Once we calculate this, all the covariances, then now what is the expected rate of return standard deviation with various correlation coefficient on here, -1 or 0, 0.3 in this case, or 1 in that case. We'll draw here the efficient frontier line of the combinations on each weight, and then finally we'll find the minimum variance portfolio model of these risky assets, where how to allocate this the weight of the debt and the weight of the equity here, and then what is the expected rate of return of this risky asset portfolio, under which what is the minimum level of the standard deviation of portfolio. Again, here forget about the risky-free assets. What we are doing is now asset allocation, not capital allocation. We finished the capital allocation with the risk-free asset and risky asset portfolio. Now this asset allocation means how we allocate two different type of risk asset into the risky portfolio here. So let's jump in. So again, if you don't understand the class notes or the textbook, please don't practice this exercise, which is totally useless because you don't understand those equations. Please read all the class notes and then practice with this the problem set calculations or exercises, and read the textbook. Then jump into this exercise. So covariance, we need to calculate covariance, which is this part, right? 2 times the weight of debt, weight of equity, times the covariances here, right? These covariances can be also calculated by this correlation coefficient times the standard deviation of debt, standard deviation of the equity. So now how to calculate this covariance then? Yeah, just as simply, we can just multiply the standard deviation of these two risky assets times correlation coefficient, which is given. You guys know how to calculate correlation coefficient, or the rate of return of these two risky assets from the historical data. And we use just correlation function, the correlation function, correl here, right? But this is given. Now here, how to calculate now expected rate of return? Expected rate of return under these 10 cases, the weight 0 on the debt and weight 100% on the equity. So how to get it? This times. Now what you want to put here fix is the expected rate of return of debt I want to fix this times 100% times 13% weight of 13% expected rate of return of the equity. So now let's drag it down. So finally we got this combination expected rate of return of each cases, right? Here now, if the weight is 2% or 20% or 80% here, right? The combination of the debt and equity. So we have now this total, the expected rate of return cases. Now, what I want to calculate also, now the standard deviation of the portfolio under this, the 4 different correlation coefficient cases. So here, how to calculate? Here, the standard deviation, we need to calculate, right? Calculate the portfolio over here or this, one of this, right? We can use, and then square root of these variances of a portfolio so that we get it. So we use the square root and open the parenthesis. Let's go to, we want to fix, that doesn't move, to the power of 2 times the weight, but I want to fix the column to the power of 2 plus, now the standard deviation of equity, want to fix the power of 2 times the weight. I want to fix, in this case, C column to the power of 2 plus, now 2 times the same way the standard deviation of debt. We want to fix this times standard deviation of equity times, now here covariance coefficient, but I want to fix this 12, this row doesn't change, times now the weight. We must fix B column times C column, which is the weight of the equity. And then let's close. So we use this equation. We cannot use this equation. Why? Because we have a different correlation coefficient that generate different correlation coefficient. So let's enter and let's drag down and let's drag to the right. So now we complete this efficient frontier line of this each combination under this different the weight. So this above line definitely dominate the upper line, dominates this on the down line, right? This also each combination dominate down part. Correlation coefficient 1 here is just linear, and we have all this, the graph under the different, right, the correlation coefficient. And here, once we complete this, then let's calculate the weight of the debt and equity that meets this minimum, right? Minimum level. So the weight of the debt or weight of the equity and expected rate of return. So I already put this equation based on this the variance of portfolio, and then we derive this the weight of the debt. We can use this equation, right? And then here 1 minus. Once we got this the weight, then 1 minus this the weight of the debt, and here we got it, right? And then expected rate of return we can also calculate based on this weight equal the weight of debt times, right, 8% plus the weight of the equity times here. So we got this, right? But I want to fix this expected rate of return of debt and expected rate of return of equity, and let's just drag it down. So finally we drew here. So the expected rate of return and the standard deviation. Expected rate of return and standard deviation on each the correlation coefficient, right? That means when we want to make the minimum level of the standard deviation, what can be the weight of this debt, right? 63%. With the debt weight of the 63%, we invest on the equity 38%. That makes this standard deviation of portfolio 0 when this correlation coefficient is negative. Yeah, definitely. Why? Because -1 is 100% diversification, right? We want to find this minimum level. When the correlation coefficient is 0, then here we find the weight, the 74% on the debt, 26% on the equity. Here now we found this standard deviation of portfolio. Given this, the correlation is 10%. So the combination of the expected rate of return and the standard deviation is 9% and 10%. When the weight is the 82% and 80% of the equity, then the combination of this expected rate of return of the portfolio and the standard deviation is 8.9% and 11%. Then finally here, when the correlation coefficient 1, 0, the diversification effect, where 2.5 means now the company, the portfolio is now here, this -1.5 is short sell, right? And with the money, and then they invest more on the debt, 2.5 times, right? This is now the weight. You can also calculate the minimum level of this standard deviation, right? Minimum level of standard deviation using the solver, right? Using the solver. These 1, 2, 3 cases, I used this equation, but this one, you can use this equation, or you can also calculate using the solver. This solver set this standard deviation minimum level by changing the cell 29, right? And then it will generate solve. Okay, it will generate, right? Here you go. It will generate the weight of debt where the minimum level of the standard deviation is 11%. So I think around here, right? 11.44 around here, right? 82%, right? This level, I think this level that you see here, this is the minimum level. Where is the minimum level of the standard deviation? It's not exactly same, right? But it's almost. Here, when the negative one, now where do you see here? The minimum level is around here, right? But it's not exactly same. But here, this level, where the weight of that is 63% and the equity weight is 38%, right? And this is the weight of this combination when the correlation coefficient is 0.3. You guys understand? Now we find this the minimum level of the standard deviation portfolio given the correlation coefficient. So the next video clips will now finally cover once we include this the risky free asset. Just as we started the capital allocation, we include this risk-free asset. Now, once we find this combination of the bond and the equity, now we'll combine this treasury bill, and then we'll find this optimal risk portfolio. No longer the minimum variance portfolio, right? But optimal risk portfolio. We'll find this. We'll find this point. So see you in the next video clips. You guys, bye bye.